In this series of videos, I will perform activities meant to demonstrate some of the named thermodynamic processes. In this video, I will illustrate isochoric heating and isochoric cooling processes between different thermal reservoirs. I will try to limit commentaries. Please watch the video carefully and pause where needed, with some exception of freeze frames. Like right now, the video is unedited. At the beginning of each video, I will go through an initialization step meant to set the N, that is the number of molecules in the heat engine apparatus, at a consistent value. In this initialization, I am setting the gas temperature at 0 degrees C, ice water, placing a 500 gram mass on the piston and trying to set the piston at the lowest volume without the piston touching the bottom. This will give us the smallest N that will ensure that the piston won't touch the bottom in the course of measurement. It's a little bit low, so I will redo it until it doesn't touch the bottom and the 500 gram mass presses in. Okay, so this is our starting volume when the gas is at 0 degrees C. As we put the aluminum can in the room temperature water, the gas will tend to expand, so I need to place additional mass, a 200 gram mass, to keep the volume the same. And as the gas continues to warm up, I place an additional 200 gram mass. There is a total of 400 grams on the piston right now. And this is isochoric heating. The volume stay the same and the temperature of the aluminum can and the gas rose up to room temperature. Now back to isochoric cooling. Here, in order to stop the gas from contracting, we have to remove the masses to reduce the pressure. Ideally, this would go back to the same position it started out with, but the piston leaks a little, so some of the gas has been lost. There's a separate video in which I characterize the amount of gas that leaks out of the piston. You can use it to do more detailed analysis. Okay, we are going to do isochoric heating and cooling between room temperature water and warm water at approximately 40 degrees C. So the gas will start out at higher volume because we'll start from no additional mass on the piston at room temperature. So this is our constant volume that we'll try to keep. And let me show the thermometer for the warm water to verify that it's about 40 degrees C. Okay, and we'll go through isochoric heating, getting ready the additional mass to place on the piston to keep the volume the same. 200 gram right now, and additional 200 gram as the gas fully heats up to 40 degrees C. Now we'll let it undergo isochoric cooling. 200 gram mass removed, and an additional 200 gram mass removed. And the gas approximately returns to the same volume it was at room temperature before. These are the total masses that I've used. So this is one run of isochoric processes between ice water and room temperature, and room temperature and warm water. We will do one more trial of isochoric processes with slightly different parameters. Thank you.